evening to everyone, and welcome to today's e-Disha session. I hope everyone's doing well in these tough times. My name is Anurad Iyer, and I'm a final year undergraduate student pursuing my bachelor's in information technology from Vivekananda Education Society's Institute of Technology. I have the immense privilege of moderating today's webinar on how to handle coding competitions. While everyone might have come across coding competitions at some point in their engineering journey, only a few know how important it really is. Most of us find coding competitions to be highly daunting and intimidating. This session will help clear up your queries regarding coding and help you use them to your advantage. I'm pleased to introduce today's speaker, Mr.Shaurya Gupta. Shaurya is a graduate from one of the most prestigious colleges of our country, IIT Patna, where he studied computer science. Shaurya has been a finalist in the ICPC, which is short for International Collegiate Programming Contest. ICPC is considered to be the Olympics of programming contests. Simply put, it's the oldest, largest, and most prestigious programming contest in the world. Shaurya has been a finalist in 2 editions of the contest, which is quite a big feat. Shaurya has previously interned at highly reputed companies such as Google, eDisha, and JustPay, and is going to work at Google Munich this fall. Before I hand over the mic to Shaurya, I'd like to encourage the viewers to actively participate in this session. If you have a question for our speaker, please feel free to post it as a comment under the live chat box. So without any further ado, I'd like to kick things off by welcoming our speaker. Shaurya, over to you.
Hey everyone. So this is a presentation on coding competitions. How do you handle coding competitions? So I'm Shaurya Gupta. I recently graduated from IIT Patna, where I was studying computer science. I have been to the ICPC World Finals twice. One was in 2018 in my second year, and then in 2019 in my third year. I hope I'm saying that right. Anyway, so yeah, I'm going to work at Google Munich this fall, and I've previously interned at Google, eDisha, and JustPay. And you can find my Codeforces profile as well as my homepage. So what is a coding competition? You're basically given a set of problems, and each problem describes some kind of an algorithm task. So what this algorithm is supposed to do is it takes some kind of input, which is described in the problem, and then the problem will also tell you what the expectations from the output are, right? So for example, if let's say the problem is find the square of a number, right? So the input will be a number, and then the output will be another number, which is the square of the input number, right? And so your algorithm must take this number and output its square. And so that's the aim, that the output of your code will generate the expected output. So you write that code, and that code must be correct. That is, it should satisfy the expectations of the problem, and it should be fast enough. So, if there are 2 algorithms and one takes 2 seconds and another algorithm takes half a second for some kind of input, and the time limit is 1 second. So the algorithm that takes less than 1 second will give you a correct answer, whereas all the others will give you a wrong answer. So why do we have these coding competitions? Why do we need algorithms? So algorithms describe a recipe for doing a task. They must be correct. So if your algorithm is supposed to make tea, or it's supposed to send a rocket somewhere, it should do exactly that task, and it should do it correctly. And then it should be efficient. So if one algorithm takes 1,000,000 steps to do something, whereas another takes 1,000 steps, then the one with 1,000 steps is better than the other one. And we need algorithms because they make our lives efficient. So a computer is supposed to make our life efficient. And then if you have different kinds of algorithms, some are fast, some are slow, then the faster algorithm is, the more you're making people's life efficient. So as an example, you can imagine the algorithms that Uber uses. they let you travel in your city for cheap. Or imagine Google search. You can search the entire World Wide Web in a single click. So that's the power of algorithms. So let's take an example. We won't go into too many details of the algorithm, but we'll take a taste of how fast and slow algorithms can be. So the problem at hand is exponentiation. So let's say the input, it's a and b. And then the task is to find a raised to the power b. And assume that a and b are integers. So how would you do that? Let's look at the naive method. So the most simple thing you can do is you take a and then you multiply a into it, so you get a square. You multiply another a, so you get a cube, right? And so on. So if you want to find a to the power 10, you have to multiply 9 times, right? And for a to the power b, it will take d minus 1 steps. Now, there's another fast way to do this. So let's look at the power. So we can split it in a clever manner. So let's say we want to find a to the power 4. So we can split it in such a way. So you take a, you square it, you get a square. You square it again, you get a to the power 4. So that takes 2 steps. Whereas by the naive method, it would take 4 minus 1, which is 3 steps. And so similarly for a to the power 8, you take a, you square it again, that gives you a to the power 4, you square it again, gives you a to the power 8, right? So it takes 3 steps instead of the old method, which takes 7 steps. And similarly for 16, you're doing 4 steps versus 15 steps, right? And then a to the power, and that number is 2 to the power 32. So it will take 32 steps instead of 4.2 billion, right? So that shows you how, just compare those numbers, right? There's 32 and there's 4.2 billion, right? And so if let's say you want to find a to the power of 2 to the power 64, it'll be like 64 steps versus 2 to the power 64, which is quite big, right? Around 10 to the power 18. And so this is, and now this only works for when a power is a power of 2, so 4, 8, 16, and so on. But for any general number, the method is quite similar, and we won't go into details of that, but it is very, very similar to this. So why do we have these coding competitions? Well, you can become much better software engineers. The code that you will write after being, once you learn how to write fast algorithms, will be much more efficient. You can give coding interviews very easily. So yeah, that's the best part. Coding interviews become super easy, and software companies will want to hire you because when you do good at coding competitions, you kind of can prove to them that hey, I know how to write fast algorithms, and that's what companies are looking for. And there's obviously the glory of performing well at all of these competitions. There are prizes and everything. So yeah. So how do you prepare for coding competitions? The first step is you learn a language, and then you learn the algorithms and the data structures. You solve problems using these algorithms and data structures, take part in online contests, and then it's a cycle. You learn algorithms, solve problems, do some contests, and you keep repeating this until you're much better. So the first question is, which language should you learn? That's the most common question beginners have. And I feel like C++ is the most appropriate language, and it's also the most commonly used. People also use Java. It's a bit slower, and the learning curve is a bit more than C++. Python is also used by some people, but it's too slow for some tasks, although it's quite easier to learn than C++ and Java. Overall, I would suggest that you learn C++, but if you already know some language, then just use that. And once you hit a roadblock where that language is becoming hard to used for all these coding competitions, you can switch to C++. So if you already know some language, just go ahead, learn algorithms, solve problems. And if you just don't know any language or are up for learning C++ or already know C++, then use C++. So C++ is like huge, just like any other language. So what all do you need to know? So learn the basic syntax, arrays, loops, conditionals, functions, strings. Then learn how to do input output. That's the basic. You want to take input and you want to give out output. So that's essential for every problem you'll solve. So learn how to do that. And then learn the STL. So STL is basically, so C++ on its own is not that big, but then you need all these commonly used data structures and functions for which we have the standard template library. And it has a lot of algorithms, a lot of data structures, but you can learn the ones that I mentioned. These are the basic ones that you must know. And then depending on what you need, you can learn more. And the same advice can be followed for Java or Python or whichever language you want to use. Learn the basics, learn some important algorithms and data structures, and learn how to do input output. So where should you learn algorithms from? So I've listed a bunch of resources. The most important is cpbook.net, which is usually called CP3 by people. So Competitive Programming 3. And yeah, that's the most important resource. That's what I used. It has so many problems. It gives you code in a way that you will actually write in competitions. So very small code, right? So the smaller your code is, the less time you'll take to type, right? And so that's very useful in an actual competition. One drawback of this book is that it uses UVA. So UVA is a website which has a lot of problems that you can practice. But the issue with that is some of these problems, they're a bit broken, right? So you'll submit your solution. It's technically correct, but then the website will say it's not correct. So sometimes that happens, which can make it frustrating for beginners. But I still managed to somehow do it, and you learn a lot. But if you don't like UVA, what you can do is just refer to this book for code and what topics to follow, and then find those problems elsewhere. So yeah. And then there are some other books. So there's a book by Skiana, which is called Programming Challenges. It's a bit dated, not as good as CP3, but it's still a classic. And then once you start learning a bit, you want some practical advice, or you want some advanced algorithms or data structures, then there are a lot of articles on Codeforces. You should refer to those. I've provided a link that collects all of these blogs, these articles, so you can also refer to that link. And then if you're looking for a book that is a bit more theoretical, you can go with CLRS, Introduction to Algorithms. It's a bit hard because you have to prove everything instead of just writing code. But if you actually go through this book, you'll become really good at theoretical computer science. Algorithms from a theoretical perspective, and you'll also be really good at proving that your algorithm is correct. So for practicing, you can use all these websites. I personally generally use Codeforces because it has frequent contests. Like every 2 or 3 days, there'll be a contest, and you can practice these contests after they're done. So it has a huge collection of practice problems as well. And then there's also CodeChef, and CodeChef also has a lot of contests, but the one that I think people should actually do is I forget the name, but it's a 10-day long competition, and it's really good when you want to learn new topics. So every month, you just do this competition. There's not as much time pressure as other contests. So this contest is very chill and you can learn a lot. And then there's AdCoder. It's a decent website, like I guess 2 3 years old, but it has very nice problems. A bit hard, so maybe you want to do these once you're more comfortable. And then if you just want practice problems, no contests, then there's Podge, and then as I mentioned before, there's also UVA. So you get all these common questions from beginners. So I'll take them. Yeah. So the first is which algorithms are important, right? There are so many algorithms. How do you know which ones to learn, right? You can't learn every single algorithm there is. So I would suggest that you learn everything that is mentioned in the CP3 book till chapter 4. So even if you don't like that book, just look at the topics and whichever resource that you like, learn all those topics from there, or just Google for those topics and learn from wherever you can. But yeah, CP3 is you can also just learn from CP3. Other question. I mean, usually what happens is, when you start doing competitive programming, you start giving contests, which is which is not something you're supposed to do. So what you want to so what happens in contests is there's a lot of pressure, and so there's not that much learning when there is that much pressure, right? So what you want to do is don't give contests, just practice. Make sure you know the first 4 chapters of CP3, right? You've done all the problems. Yeah, you've mastered it. Once you've done that, you'll find that at least the beginner contests, you'll do really well at them, and you won't have any knowledge gaps. So you might not be able to solve a problem because of time, or maybe you didn't get the idea, but at least you will know all the core concepts that all these problems will use. So I highly recommend that you don't do any contests. You just practice the first 4 chapters. It can take 2 months, 3 months, maybe even 4. But yeah, once you do that, your fundamentals will be very strong. And then what do you do when you're not able to solve a problem, right? So maybe you're practicing, maybe you're giving a contest and you are unable to solve a specific problem. What do you do? So what I do is I mark it for later, right? Maybe I'll try it after a few hours, a few days. And even if I'm able to solve it, great. But if I'm not able to solve it, I'll look for hints. So let's say it's from some book, then that book might tell you which algorithm you're supposed to think about. Or if it's from some contest, right, there's generally some hints in the solutions. So look for those hints. Maybe ask somebody. Yeah. And try again. If you're still unable to solve, it's okay to give up. So just read the solution, but don't read the code. Write the code on your own, so at least you'll practice how to write the algorithm. And then once you're done with that, you should come back to that problem after 1 or 2 weeks when you've forgotten the solution, and then try to solve it again. So this is a very nice way to not just solve a problem, but also learn more from it. Another thing that many beginners say is they can solve problems when practicing, but then when they're actually giving the contest, they are not able to do well. So again, as I mentioned before, contests have a lot of pressure. You want to get as many problems solved in 2 hours. And yeah, you have to be super fast, and that leads to mistakes. Yeah, and under pressure, sometimes you're not able to come up with a solution. So it takes time to get better at contests. You should be very patient. So even if 10, 20, 25, 30 contests, 40 contests don't go well, maybe 10% of them are good and the rest are not so good, it's okay. It happens. And try to focus on correctness. So let's say it's a very easy problem. You can write the solution in 2 minutes. Take 3 minutes, take 4 minutes, but make sure that all the edge cases, all the corner cases, everything is correct. Make sure you didn't make any mistake, right? You wanted to write I++, but you do C++. Just make sure that your code is correct. come up with test cases, and then see if the code that you wrote runs correctly on that input. And so once you start improving your accuracy, then try to increase your speed. And finally, after a contest, there will be many problems that maybe you weren't able to solve because you didn't know how, or maybe you didn't have time. Make sure you solve all those problems, like every single one of them. It's very important. And then obviously there'll be some problems that are way above your level. They're super hard. Maybe they involve 3-4 algorithms or some advanced mathematical concept. Mark it for later, don't do it now, right? But as you become more advanced, you start getting better, come back to them. Another question is, people are scared of coding competitions because they think there'll be a lot of math involved. But in general, most problems, they don't require much math. So just basics like induction, very basic stuff, and graph theory. So you should know so the chapter 4 of CPT is graph theory. So yeah, you should know that chapter well. And then combinatorics, basic stuff that you might have learned, permutations, combinations, etc. And then eventually, once you've started becoming good at computer programming, you can learn some advanced concepts like number theory, geometry. Yeah, you generally don't encounter geometry in easy problems, but yeah, there might be some easy number theory and geometry problems that you can just solve from your common knowledge. And so these are some prestigious coding competitions that you should take part in, but not in the beginning because they're not that easy, right? So this ICPC, which is like the Olympics of coding competitions, it's team-based, so you have 3 people and they code on one computer, right? And so at a time, one person will code while the others come up with solution for the other problems. So that's what ICPC is like. And then there's Google Code Jam, which is a solo contest, and it has various stages, and people get eliminated at every stage. And finally, there are 500 left, I think, in round C, and then the finals are like 20 people or 30 people who go to some Google office anywhere in the world. And then they compete live. And then there's Google Kickstart, which is easier than Code Jam, and it happens every month for 6 or 7 times a year. Yeah, and yeah, if you do even decent at it, let's say, I don't know, 200 rank, 300 rank, you can get an interview at Google. So keep giving these regularly. There's also Facebook Hacker Cup and so many others. Even all these websites that I mentioned before, Codeforces, CodeChef, they have a lot of contests, and then they have some specific contests, like some company will host them. So yeah, you can give all of those as well. You'll get some awesome prizes. Maybe the company will invite you to the office. So yeah, just keep checking those websites regularly. So to conclude, coding competitions, they require patience and a lot of practice. And all these competitions are like actual sports. There's a lot of adrenaline involved, so they're super fun. And in the end, after trying a lot, maybe you're not good at them, right? So don't waste your time. Do something else, but at least know the basics, like the basic algorithms. And then there are other ways to get into Google and Facebook, other ways to become really good software engineers. This is just one of them. And in the end, you should make sure to have fun. Good luck.
Thank you, Shaurya, for the talk. That was extremely informative and detailed. I can't thank you enough for sharing the resources that you have used throughout your coding journey. I'm certain that it will be of immense help to the students.
Hey, hi Anirudh.
Hi, Shaurya. It's my privilege to have you here. So without any further ado, I'd like to commence with the question answer session. I urge the viewers to post their questions on the live chat box. We'll try to answer as many questions as possible. So here goes the first question. It's from Faizan. Can you suggest good text editors which may help in saving time by auto completion and minimizing silly errors?
Hi, Faizan. So, personally, I would use Sublime Text when I was doing coding competitions. You can also use VS Code, any of these general, very popular text editors, or even Vim, because with Vim you can save a lot of keystrokes. And for so let's say you're using C++, so you want some language related features, right? So autocomplete, etc. So for that, I would suggest you use something like ClanGD. So it's spelled as CLANGD. So it basically you can use it with any text editor, and then it will provide. So it will let you know what all bugs are there in your code. So syntactical errors, and then all compilers it'll show you as, and it will also give you autocomplete. So in the beginning, I would suggest that you don't use any of so you don't use ClanB, but you use a text editor, and then once you're getting good, right, you can use ClanB because it will help you save time.
Okay. Thank you. Moving on to the next question, which is from Shivam Singh. Can you provide some tips on keeping your nerves in check during those tough hours of actual coding competitions?
Right. So I don't think those nerves go away because so I remember during one of these ICPC contests, we were writing a solution that was like the deal breaker, and then we submitted the solution in the last 10 seconds, and that was super nerve wracking. So those nerves don't go, but with practice, you can learn to keep them in control. Yeah.
I'd like to delve deeper into your mindset before a coding contest. So, what is it that you go through? Do you follow any particular routine before a coding contest, or do you just go all out on the last day?
Huh. So let's say I have ICPC coming. I'll
Mhm.
make sure to have a team contest every day for so 2 weeks before the contest. I will do a contest every day. That lets you sort of get into the mood. Besides that, not much really. Just make sure you have enough sleep
Okay.
and keep your calm.
Okay. For those who are just tuning in now, ICPC stands for International Collegiate Programming Contest, which is quite a prestigious contest for which Shaurya has been a finalist in 2 rounds. So moving on to the next question, which is from our HOD, Dr. Mrs. Shalu Chopra. Do ranks on competitive coding website help you in getting an internship or a job?
Not really. I don't think these ratings really matter much, but they will certainly help you get noticed. So let's say you have, so it depends on a recruiter really. So if the recruiter knows what the true meaning of these ratings is, then it might be useful, but generally they don't. So yeah, I don't think these ratings matter that much, except for showing off in the community and having an estimate about your own skills.
So there's a wide array of coding challenges and coding websites available
Yeah.
online. So which one do you prefer?
I generally use Code Forces because the interface is nice and they have nice problems. But I would also suggest AdCoder. Their contests are a bit harder, and you get exposed to different kind of problems. CodeShare is also nice, but only the 10-day long contest they have. I forget the name. Uh, yeah, I think it's called Long Challenge or something. But that contest is really nice for learning new concepts.
Okay. Moving on to the next question. Can you share your experience as an intern at Google?
Yeah, sure. So I worked on ClanD, which I mentioned before. So Google uses that for their C++ auto completion inside Google, and so I was working on that project, and yeah, it was a lot of fun. I got to learn a lot. My team was super helpful, and yeah, it's a really fun experience overall.
Okay. Can you please shed some light on the interviewing process for Google? How
Yeah,
did you get
absolutely.
selected as an intern there?
So I had a friend who was already working in Google, and I asked him to refer me. Yeah, I mean, after that, the interviews themselves were very easy because the problems were like basic problems that you might encounter in a coding competition. So from that perspective, it was easy. But I think the most important bits in Google interviews is that you make sure that whatever you're thinking, you think out loud. So maybe you have some ideas in your head, but you're not speaking them out loud. So it's very important that you tell your interviewer what you're thinking. And then even if you're stuck, don't lose your calm, but just ask them for a hint. Tell them what you're thinking and then ask them what they think. Right. And so they generally give you a hint because they understand that sometimes people get stuck. You can't always come up with the solution on the go. Yeah. So these are some important things.
Thank you. Um, so Hiroshima Angom has a question for you. Which coding language should you learn first and why?
Yeah, as I mentioned in the slide, I use C++ because, uh, yeah, I mean, there's not really any task that you can't really do with C++. So you can't go wrong with C++. And it's not that hard to learn. At least the things that you need at a coding competition, those are easy enough. So, yeah, I would suggest learn C++ and then you can learn any other language that you might use outside of coding competitions as well.
Why do you prefer C++ over Java or its other counterparts?
Right. So mainly it's because so Java there's a bit of learning curve because it goes straight into oops from the get go, whereas in C++ it's like you can also write it like you're writing C, right, and then whenever you need you can switch to more oops centric. So that's why it's like if you want to do C you can do C, if you want to do oops you can do oops. So that's why I prefer C++.
I've been told that you are a big fan of functional programming over object-oriented programming. Why is that
That's
so?
right. Uh, so with functional programming, it's like so let's say in C++ you have a global variable and then you have two functions, right? So unless you read those two functions properly, you don't know whether they're going to interact with the global variable, right? Whereas with functional programming, it's generally they are immutable. They don't have any global variables. So that means if there are two functions, you can look at them separately, right? And they won't interact with each other. Running one function won't change the other function. Everything is isolated. And then there's also in functional programming, there's a lot of mathematical ideas. So overall, it's when you write code, it's like writing equations, and so you can focus more on the logic than you focus on the data and the pointers and everything.
Okay. Um, the next question is from Harshita Kanal. Did you prepare a specific code template which you used for writing code during competitions?
Yes. So again, it depends. So let's say going for ICPC, then I would suggest that your template is very small. Whereas if you're giving a contest from your own laptop, the template can be as big as you want it to be. So I would generally suggest that try not to use templates, but there are a few things that you might need there. So for example, some functions are a bit too long while writing, and if your typing speed is not that fast, then maybe you can have shorthands for those, like pushback can be PB, etc. So so yeah, I mean, you can find all these templates. So whenever you just go to Code Forces, look at some highly rated people there, look at their solutions, you'll see the template, right? And so it's a nice way to learn from other people's code. Go to Code Forces, read solutions there, so you can think how other people are thinking, and
Okay.
that's a really good tool for learning.
Okay. Um, so Charushila Nehete has a question for you. What is Haskell programming? And the second question is, what was your job profile with JustPay?
Right. So with JustPay, I'll answer the second question before.
Sure, sure, sure.
So with JustPay, I've been sort of interning there since January, and yeah, I'm writing Haskell there, and so Haskell is it started as a research language in the 1990s, But now it's being used in a lot of places. So Facebook is using it, many investment banks are using it, and so it was a research language that became a bit popular, and it has a lot of ideas from academia. So you get to learn more about the internals of compilers, and you get to learn more about advanced programming language concepts. uh, yeah, and it's a functional programming language. So when you write Haskell, it feels like you're writing a mathematical equation.
So is it close to assembly language, or is it more of a high level language?
I would say so. So basically, you have OOPS, right, and then you have functional programming. So the object-oriented languages, they're based on the Turing model, and so they're more close to the assembly language, right? So if you look at C and if you look at assembly language, it's not hard to imagine how you can compile C to assembly, right?
Hmm.
Whereas with functional programming, they're based on lambda calculus. So lambda calculus is equivalent to Turing machines, and so lambda calculus is a mathematical model, which is why functional programming languages feel like you're writing mathematical equations, and so it's more close to lambda calculus than it is to assembly language.
Okay. Moving on. Vijay Lakshmi Muralidhar has a question. Can you give us some resources where you can get a set of programming challenges that can help students practice for coding challenges?
Sorry, could you repeat the question?
Yeah. Can you give us some resources where you can get a set of programming challenges that can help students in solving the questions? So basically,
So
something which they can use to practice.
yeah, I mean, as I mentioned all these sites before,
Mhm.
so let's say you go on Code Forces, right, and you want to practice binary search. So Code Forces recently introduced tags, right? So you can go to the tag binary search, and then it will show you all the problems that require binary search. So in that way, you can get a set of problems that focus on a specific topic, and then you can sort these problems by the difficulty. So it's a very nice way to learn a new topic. Start with the easier problems and gradually move on to the harder ones.
Okay. So, which method, according to you, is the best way to learn programming languages? Because there are a wide array of online courses available through which we can learn. But the problem with them is that you sometimes get stuck
Right.
uh, in tutorial purgatory, and you don't know what to do and how to get out of that slump.
Right. So let's say you're a complete noob. In that case, I would suggest to go with CS50. So it's a very popular course on edX, and it's an introduction to computer science, and it has a lot of things. So you get to learn a new language, and then you get to learn some basic algorithms and data structures. So it's a mixed course, but the best part is it has a very big community. So let's say you have a problem, you can go to their Q&A page and just post your doubt, and then somebody will help you. But they're already so this course is they're all around the year, so you'll see that many of the questions you might have in mind are already there. So overall, I would suggest that you do CS50 because it's a really nice course. You get to learn a lot, and once you've done CS50, you'll be confident enough to move on to any other language.
Okay, thank you. Um, okay, Roshan Asrani has a question for you. Which resources or websites will you suggest uh, to optimize his algorithms? So if a student wants to optimize their algorithms, so what all websites should I refer to?
I don't have any specific website in mind, but I think it just comes with intuition, or if somebody tells you, how you can improve your algorithm. So one way is that you look at some classical problems. So generally, these classical problems have three or four different ways of solving them.
Hmm.
And so what that helps you learn is you get this intuition behind uh, realizing whether there is a faster solution to your algorithm. So yeah, so for example, you want to search something in a list. So you have binary search, you have normal search. So you get all these comparisons on standard algorithms. I think that's a good way to learn how you can optimize. But in general, I don't think there is a resource that will tell you if you can optimize it, except for if, let's say, you go to Stack Overflow or you go to Codeforce's blog and ask people over there.
Okay. Uh, how do you decide which data structure would be more suitable for the given problem?
Again, that usually comes with intuition, but yeah, so wherever you're solving a problem and you need some kind of a data structure, just write down what all you actually need from your data structure. So maybe you need fast search, maybe you don't need as fast search as you need fast insertion, right? So there are all these factors that you should write up, right? And prioritize what's more important. And then based on your knowledge of the data structures that you know, you'll have to make a decision on what's the most useful in your situation. Again, these are all things that come with practice. You can't know from just by learning the data structures, but you
Hmm.
can learn by using them repeatedly.
Okay. So the first thing that stood out to me when I read about you was that you're an IIT Patna student, graduate from IIT Patna. So could
Yeah,
you please shed some light on your journey, on your IIT journey, and uh, the best moments of your college life?
yeah, sure. I mean, it's pretty much the same as any other IIT person.
Oh,
I mean,
is that so?
yeah, I mean, I gave JE and it was okay-ish. Yeah, not much to talk about there.
Hmm.
Yeah, I think most nice moments were, I guess, going for ICPC and even practicing for ICPC, because you have your teammates and you spend a lot of time practicing. So those were some good moments of my college life.
Okay. Mrs. Vinita Mishra has a question. What do you enjoy most about programming?
Aha, that's a nice question.
Hmm.
Uh, I think it's mostly problem solving. There can be 100 different ways of doing something. Uh, but you're always looking for the fastest way, the most elegant way, and there's a little bit of mathematical touch to it. You try to you try to prove that your code is correct. It doesn't have to be formally proved, but in your head you try to prove it, and all these kinds of things make programming really fun.
Okay. What made you pursue programming in the first place? So,
uh,
what fascinates? What's the thing that fascinates you the most about programming?
I think the most fascinating thing is you don't need much. You just need your laptop and you can do really anything that you can dream about.
Hmm.
So it gives you a lot of power without much investment, without any tools.
Okay. Okay. So the next question is, can you tell some applications of data structure in real life preferably?
Yeah, yeah. So let's say you have your text editor, right? And there are some text editors that, let's say you open a text file that's like 1 gigabytes long, uh, and it will still work very fast. So that's thanks to some nice data structures that they use for storing the text. Uh, yeah, I mean that data structure is, it's quite cool. And then let's say you have your browser, right, and you go back and forth. So uh, it maintains a list of, like, so when you press the back button, it shows you what all you can go back to, and then it also maintains what's in front of you. So it's a very basic data structure, but you can see in real life uh, a data structure like that might be implemented. What else? So
So,
all of your compilers, all of your operating systems, they use
hmm,
a lot of fancy data structures,
hmm,
right? So maybe they want to maintain a list of processes that are running on your operating system, or let's say it's your file system, and all of these things, they're based on sophisticated data structures.
okay,
So yeah, I mean, data structures are very important, very fundamental to everything that we do.
okay. So we have another question from our viewer. Should we remember advanced algorithms?
Sorry, could you repeat that?
Should we memorize advanced algorithms?
Yeah, I mean, it depends on what you want to do. So let's say you're getting good at competitive programming,
Hmm.
and you want to you want to get even better, and you're trying to, let's say, crack ICPC or Google Code Jam, etc., then I would suggest that yeah, you should learn advanced algorithms. So some advanced graph algorithms, some advanced string algorithms, max flow, all these things. It becomes useful then. But let's say you're going for an interview, then I would suggest that don't waste your time on advanced things. Just make sure that you know your fundamentals.
Okay. So do you have any advice on as to how to crack interviews?
Yeah, so I would suggest that you do lead code, that it has nice problems that you might see on an interview.
Hmm.
Make sure that you know all your basic data structures, how to implement them, and you should also know all the basic algorithms. And then what I would suggest is you try to implement some of the algorithms that are used actually by, let's say, your operating system.
Hmm.
So yeah, I mean, I can't think right off my. So let's say right. So let's say on your system there are something called blacklisting. So it's a data structure that lets you blacklist some URLs. So if you search for it, you can find it. But basically, you can blacklist some URLs, and so you want to write a data structure that uh, so you give this data structure a query. Is this string blacklisted? And then it will quickly search through the list of blacklisted strings it knows and will tell you whether it is blacklisted or not. So it's a very simple thing, but it is actually uh, used by our operating system. And so I mean, all these very basic things they might ask you in an interview, but yeah, I mean, overall, just know your fundamentals, practice on lead code, and during an interview, make sure to be vocal about what you're thinking. Yeah, I think that should be good enough.
Okay. What advice would you like to give to a person who is starting to code from scratch, who wants to get into competitive coding like you?
I would suggest that don't give contests, just
Hmm.
practice, and make sure that if you're not able to solve something, you you look at the solution maybe, but you come back to it later. And overall, whatever you've done, make sure that you understand it properly, right? You know how to code it, but you also know the fundamental, you know the fundamental of how the algorithm works or the data structure works.
Okay.
So you should be very familiar. They should be like in your heart, you know. Like, yeah, there should not be anything that you don't understand about them. So I would say go for understanding rather than uh, writing just code.
So we have another question. How is competitive programming different from real life programming?
Uh-huh. So in real life, you don't. I mean, it depends on what you're doing, right? So let's say you're somebody who's working on fundamental things like compilers, operating systems. In that case, you might encounter some algorithms or data structures, but overall, generally, what most software engineers do, they don't really write that many algorithms or data structures. Yeah, because most of it is available as some sort of a library, right? So why would you redo everything?
Hmm.
So real life software engineering is more about how clean your code is, and it's about how well designed it is. So how well you have separated it into, let's say, classes or modules. So those are the things that matter more. Yeah, and then it becomes more about the advanced concepts. Let's say in C++, there are so many advanced things. Then it becomes more about those than advanced algorithms. But the way that competitive programming helps you with software engineering is that uh, it develops the thinking that is required to solve hard problems. So you might not use any of the algorithms or data structures in your life, but uh, the thinking will always remain with you. It will transform the way you think.
Okay. Uh, I think we're out of questions. So I'd like to go a bit off topic and ask you what's keeping you occupied during these tough times?
As I mentioned, I'm doing my internship sort of at Just Pay.
Hmm.
So yeah, that keeps me busy. But yeah, not much really.
Okay. So thanks a lot, Shaurya, for the talk. That was extremely informative and detailed. And I can't thank you enough for sharing the resources with us students, which will be of immense help to us. Without any further ado, I'd like to commence the question answer session. And I urge the viewers to post their feedbacks in the links that is given below in the description box as well as the live chat box. So, and I'd like to thank you on behalf of my college and the entire fraternity of management. And yeah, so that was it for today's session. And I hope you all have some takeaways and are leaving with a better understanding of coding competitions and how to use them to your advantage. I'd like to thank you all again for being with us. Please do tune in for tomorrow's eDisha session, for which the Google Meet streaming links will be shared soon. I'd like to conclude the session by urging everyone to stay indoors as much as possible and stay safe. Until the next time, don't go changing.